Okay, you are welcome again to this um, our channel. Now we are asked to solve this question is on differentiation. Differentiate with respect to x. Y equals to cos x all over 1 plus sine x all cubed. So let's see how we're going to solve this problem. So we'll start. So now this has it's division. It has division, so we can say okay. So let our u be equals to cos x all over 1 plus sin x. So that's our u. Now that means the function will now be equals to y cubed. So now the next thing we need to do is to differentiate. Let's differentiate with respect to u now. That will be dy du equals to 3u squared. So we now have to take u itself and differentiate with respect to x. So we now have so in this case we will let's copy this our u. Let's copy it here. So let's copy it there. So in this case now, let a be equals to cos x. So we now have something like this. The a, the x, that will be equals to minus sine x. Then let our b equals to 1 plus sine x. So we have something like this. The b, the x is equals to cos x. So this is quotient. We have to apply the quotient rule. Apply the quotient rule. So we apply the quotient rule, which is du dx will be equals to b dA dx minus, this will now be a db dx all over b squared. So this is the quotient rule. Now we have our du dx. So remember our b is equals to 1 plus sine x. Then the a dx is equals to minus sine x. So I'm going to put minus sine x here. Minus, so our a is cos x. Then our db dx is equals to cos x. So if we look at this, our b is 1 plus sine x all squared. So let's work on this. So open up the bracket for the numerator. So you have minus sine x minus sine squared x minus cos squared x all over 1 plus sine x all squared. So we can still work on this and factorize out. So equals to minus sine x minus, so we have sine squared x plus cos squared x. So this one is 1 plus sine x all squared. So in this case we have du dx. Now I want you to remember in our trig identities that this one that I'm highlighting here from our trig identities, everything there is equals to 1. Equals to 1 from our trig identities. So this is equal to 1. So I want you to take note of that. Is equals to 1. So I want you to see what I'm doing very well there. So you can see now if we move to the next stage, let's bring this man down. So du dx. So now we can rewrite this. It will be minus sine x minus 1 all over 1 plus sine x all squared. So we can work on this the more. We can say that this man, 1 factorize 1 out, so we have sine x plus 1 all over 1 plus sine x all squared. So for the sake of this, let me just arrange this minus into 1 plus sine x 1 plus sine x all squared. So at the end of the day, we have something like this minus 1 all over 1 plus sine x. So that's our du dx. So now using the composite rule, using the composite rule, or they call it chain rule, our dy dx equals to, now that will be dy all over du times du all over the x. So we can bring down dy all over the x. Our dy du, for the sake of, don't want to rush it, our dy du, what we got is this one. Our dy, this is our dy du. So don't forget that our dy du is equals to this, is equals to 3u squared. So I'm going to bring it down. So we now have that. Then our du dx is this man. So we have that. So we can expand this. This will now be 3. Let me open a big bracket. So we now have our u. Remember our u is cos x all over 1 plus sine x. So everything all squared times. So I'm going to copy this and bring it here. So our dy dx is equals to 3 cos squared x all over 1 plus sine x all squared. So minus 1 all over 1 plus sine x. So that we have. So at the end of the day, what we have at the end of the day is this minus, let me put 3 here, minus 3 cos squared x all over this one That would be 1 plus sine x all cubed. So this is our dy dx. So our dy dx, is equals to this. So this is how to go about solving this problem. So let me tell you, in this case, why this one is 1. So let's put a reason for that. Sine square x plus cos square x equals to 1. So, why this one turns to 1? That's why I'm putting that. So now we have our final solution to the question. So let me close this. So this is the solution to the question we are given. So this is how to go about solving this type of problem. So thank you for watching. So we'll see you again in the next video. So please don't forget to like this video, subscribe to this channel, and click the notify button so that when I produce another new video, you'll be notified. So thank you for watching. See you again in the next video.